This video is part 3 of Chapter 10, Quasi-Experimental Designs and Program Evaluation for PSY 222, Research Methods in the Psychological Sciences. Now, last time we had talked about a variety of threats to internal and external validity and laid out the difference between non-experimental, quasi-experimental, and true experimental research. Now we want to walk through an example. For example, does taking a research methods course improve your reasoning ability? The independent variable, maybe you want to compare students who are in a research methods class with students who are in a developmental psychology course. Your dependent measure, a 7-item test for methodological and statistical reasoning ability. And let's say that you did observe group differences at the post-test in the predicted direction. So you're taking students who are signing up for psychology courses, some who are taking research methods courses, and some taking developmental courses. And you've given them this test at 2 points in time, and then you want to see, do the research methods students outscore, so do they get higher mean scores than the developmental students? Now, what if you saw this pattern of results? In this case, with the description that I've just given you, what you have is a non-equivalent control group design. So you have 2 different groups of students. What you're not controlling for is who's more likely to take the research methods class. Thinking of my own department, developmental is very popular with non-majors. The only people taking methods are majors. So they may be different to begin with. You just don't know. So you have no mean difference here. You have a mean difference here. You can't necessarily know, despite the fact that having a comparison group allows you to control for things like history and maturation and testing, instrumentation, and regression, but you have other threats that you can't control for, such as unforeseen differences initially. Now, the design isn't worthless. I mean, you do have a pre-test result that shows no significant differences. And you do have a post-test result that shows significant differences. What you have to be careful about is the way in which you explain the post-test differences. You have to start by asking questions: what threats did you not rule out? So you do have selection issues. As I said, you're not randomly assigning the participants to either receive the treatment or not receive the treatment. People chose which classes they were in. They may be at different times of day. They may have mixtures of majors and non-majors. So they're probably not equivalent in a lot of other ways other than your pre-test dependent measure. That dependent measure also, it may have issues of reliability that you're not aware of. So we have to be concerned about the selection effect. There may be these pre-existing differences that eventually account for the difference we see at the post-test. There also may be a whole slew of possible selection effects that are additive. So you may have selection issues. You have people who signed up for 2 different classes. They may have different motivations. They may have had different experiences previously. They may have been exposed to different historical effects, given maybe their classes are in different buildings. Maybe there were issues in those buildings. Maybe their teachers were very different. And you just don't know how those impacts may have played themselves out. You may have different dropout rates, and you may have differences in terms of regression to the mean as well, in these sort of additive situations. With what's called a simple interrupted time series design, and it sounds more complicated than it is. In the simple version, you have researchers who make a series of observations rather, before and after a treatment. So what you're doing here, you have X is the treatment, you have a bunch of observations, you intervene, and a bunch more observations. This helps you to kind of establish a more reliable average behavior, both before and after an intervention, so that you don't have the instability of the measure to deal with. Evidence for the treatment effect is demonstrated when you have seen an abrupt discontinuity, as it's called. So after the treatment, you see either an abrupt increase or an abrupt decrease. And you see it every time the treatment is implemented. The major threats to internal validity in this type of design are history effects and instrumentation effects that may happen at the same time the treatment is applied. Now here's an example that I pulled from your book, and what I would recommend, I put images in like this to kind of remind you to take a look at this a second time in your text. And they gave the example of self-reported character strength, which has embedded measures of things like gratitude, hope, and kindness, etc. And they took advantage of the fact that there was an actual event to give you this example, they meaning your authors. They were measuring these things over time, and 9/11 happened. Nobody could have predicted that, but they were taking these series of measurements. Here's this event that serves as an intervention, and you see a change. Now, what you have to try and do is figure out, what is the causal variable here? You know that there's a historical event, and it may have an impact, and that it is a very abrupt change in people's reported responses. When you do a simple interrupted time series design, there are some threats that you can rule out. You're able to rule out maturation because the changes that you're implementing you're measuring across time. So you're not going you're going to be able to document those sorts of gradual changes. Your testing, let's say, an example that we could use is if you're looking at GPA as a variable. If testing influences performance, you're likely to see these in the initial observations long before the intervention. So it won't impact your actual your ability to make the inference after the intervention and the study is over. You can rule out regression effects because you're making multiple observations. Again, if you're going to see regression to the mean, you'll see it after the initial measures, and the behavior will eventually stabilize. Time series studies can also be done with non-equivalent control groups. So if you remember that non-equivalent control group design with the observation, the intervention, the post-observation, compared with a group that just has the pre-test and the post-test, it's a simple non-equivalent control group design. You can also do that with a time series. So you can have multiple observations prior to the intervention, and multiple observations after the intervention. With the comparison group, the control group, you do multiple interventions, no intervention, or multiple observations, no intervention, and then again multiple observations. What this requires is that you are able to find a group that's comparable enough to the treatment group and has the same opportunities for multiple observations before and after the timing for when the intervention is applied. These designs can be time-consuming, as you might imagine, but they do have the benefit of controlling for some of the problems, the threats that we've been describing in this chapter. Now, this is an example of a situation where these researchers were looking at hospital admissions for heart disease in 2 cities, Bowling Green and Kent, Ohio, and they were looking over 6-month periods of time, and it was 2 time frames. So you have January to June, July to December, and they then had these 2 groups represented a treatment and a non-equivalent control group. In Bowling Green, you had the implementation of a policy that represents the intervention. The smoking ban went into place in Bowling Green, and what they wanted to do, and notice that they're measuring 6 observations. The intervention, which was the implementation of the smoking ban in Bowling Green, did not happen in Kent. I'm sure they reported a bunch of demographics that you had to document some similarities between the 2 locations, but there are considerable differences. The key is that over the course of this initial phase, you have rough equivalency in the levels of hospital admissions for heart disease. After, you start to see a decrease in the Bowling Green numbers that I would guess, if you did significance testing, would show mean differences between the 2 cities. Now, you can make the inference that the smoking ban, at least potentially, could have had something to do with that. Now, notice the careful choice of words there. There are lots of factors you still haven't controlled for. You haven't done a random controlled trial. And that would be, the gold standard for causal inference is a random controlled trial. As for naturally occurring events like the implementation of a smoking ban, to be able to bookend it with 6-month observations on either side is a pretty good test. Not a perfect test, but a pretty good test. Program evaluation studies, and I mentioned in part 1 of this chapter that I've done some of these studies. They can be very hard to do, or I should say they can be very hard to do well. What you're trying to do in program evaluation typically is to determine the effectiveness of services that organizations provide, policies that have been implemented by government, for example. You also may want to be able to give feedback to the administration, to granting agencies. One of the studies that I was involved in, for example, they needed to be able to document their program's effectiveness in order to get continued funding from a granting agency. So that's where I was brought in to do some interviews and collect other data as a part of a program evaluation study. Evaluators will do things like determine the organization's needs, do a description of their processes, try to identify their key outcomes and indicators. They may measure efficiency. Sometimes they're actually doing linkages between those things, so doing a needs assessment, monitoring the implementation of a program and monitoring the process, and then assessing the outcome and providing that information to the organization itself to improve its work. And here's where you start to see kind of the interaction between basic research and applied research. When I go into a program evaluation situation, I take all of my knowledge as a social psychologist to that situation with me, and I try to apply some of the basic theoretical ideas to the problems that need to be addressed, that need to be assessed in order to improve operations. So I'm taking advantage of my knowledge of basic research and applying it to a very specific situation. Now, your authors make this statement, despite society's reluctance to use experiments, we have a tendency to stigmatize the true experiment. And, part of this is the historical legacy of the Milgrams and the Zimbardos of the world. But also the practicalities, the pragmatic issues that come with doing random assignment and high levels of control. Since that's the case, yeah, I don't know that it's so much society's reluctance as just the practicalities make true experiments difficult to do. Quasi-experiments tend to be an excellent way to do program evaluation very well. And while it doesn't give you the highest level of ability to make causal inferences, it does a good enough job that you can get good results, reliable results that are informative, and that's really the key. So why do we spend so much time in this chapter talking about threats to internal validity and threats to external validity? We know that we're going to have to use quasi-experimental techniques. So we have to go into that with our eyes open, understanding what the limitations are so that we aren't making claims that we shouldn't be making and pushing programs that really shouldn't be pushed based on the data that we have available. So 4 questions that your authors suggest you ask yourself when you're engaging in program evaluation, or 4 types of questions that you might be asking when you're engaging in program evaluation. First is a needs assessment. You could do this in terms of what does the organization need in order to do its job. So you take the organization's stated goals and mission, and then you find out, are those stated goals and objectives, are they actually being met? And then you can kind of retool that. What are the actual needs of the people in the agency? And then backward design it. So one study that I was involved in, I was asked by what was at the time the Mental Health Board, to do some focus groups and surveys with people with mental illnesses in Stark County to determine the barriers that they were running into. It's not a straight needs assessment, but they wanted to know, they have stated goals and objectives to meet the treatment needs of the population of people with mental illness. They asked me to assess the degree to which people were in different constituency groups were facing barriers, like inaccessible care, financial barriers, insurance barriers, and so on. So that's the kind of assessment you're doing there when you're talking about alignment of the needs of your consumers and the goals and objectives of your organization. You may also be doing an assessment process. Another program evaluation study that I was involved in, I wasn't the lead on this one, they wanted to look at implementation of programs. So these were already pre-existing programs. They had not been assessed previously, and what was being asked was how efficiently are these programs being rolled out. And what you want to do is observe the process as it's being engaged in, and then document it. So this is, fundamentally an observational study. There's also outcomes research, and here, I talked about needs assessments sometimes being tethered to the stated goals and objectives of an organization, and then backwards designing. So you know what the agency is up to. Now I want to know what are the baseline needs of the people that this agency serves, and how does that relate to what their goals are. If their needs are different from the organization's goals, then that's a problem. So we use surveys and interviews and focus groups to find that out. Outcomes research, when you get down to the point of saying, okay, I've got these goals, am I meeting the goals? Then you can use quasi-experimental designs. Sometimes you can do actual experimental testing. Sometimes you just pull records and do archival research. Finally, you can do some efficiency research. Often this is tied to asking process questions as well. You can do analyses of cost effectiveness, efficiency in terms of resources, and that may involve comparisons to other kinds of programs that could be used. It's possible that you could do experimental or quasi designs, and just like with outcomes research, you may be pulling archival data as well. Personally, I find program evaluation fun because you get to work with professionals who are out in the world dealing with real world problems and real consumers. I find it kind of refreshing to get out of the lab, talk to folks who are kind of in the trenches, trying to solve real life problems. So it can be fun. At the same time, it can be super challenging because the real world is awfully messy. Sometimes it's nice to just be in your lab where you can control everything. Doing these studies, it's a lot different because there are many uncontrolled factors and a lot of challenges arise because of it. Now, before we leave this chapter, we need to talk about the difference between basic research and applied research, and the fact that the two are inextricably tied together, or at least they should be. Your authors talk about the relationship between basic and applied research as reciprocal. That means that, we do a lot of basic research where I've often heard this defined as doing research for its own sake or for the sake of knowledge. In psychology, we often, there is a lot of basic research, especially in experimental psychology, where you just want to know how things work, and you want to be able to document it. At the same time, though, rarely are even our most basic research questions, rarely do they not have some kind of applied value. Otherwise, it's difficult to justify the work. Essentially, basic research gives you the backdrop. It allows you to have logical propositions that you can make about, as your authors put it, behavior and mental processes that you can then use in applied contexts. So we take the principles that are laid out through basic research and we then apply it into the messy real world. In order to solve real world problems. The complexities of the real world have to then be incorporated into what we know. So the basic research is often more experimental in type, and then the applied research may be more quasi-experimental, even observational in nature. Adding those levels of complexity with full awareness of the types of internal and external validity threats that are likely really reinforces that idea that your authors have been pushing for 10 chapters, which is you need to use multiple methods and multiple approaches to every problem in order to understand it fully. And that concludes Chapter 10.